The majority of today's commonly used digital instruments have a set of UI elements that may involve complex operations. Using augmented reality tutorials that superimpose visual instructions directly onto the instrument is a great way to walk users through such operations. However, creating AR tutorials requires expertise in programming and proficiency in manipulating virtual content. That's why we created InstruMentAR, an automated way of creating AR tutorials through tracking the user's embodied demonstration. InstruMentAR supports 5 types of UI elements and their associated operations. Since tracking the UI elements directly is infeasible due to hand occlusion, we propose to track gestural movement during UI manipulation instead. To achieve this, we designed the hand wearable with 2 pressure sensors to precisely detect when the user's hand starts and completes manipulating the UI elements. The pressure sensor is attached to a force transfer pad, which allows it to detect forces that are not applied directly to it. The conductive tapes allow the user to interact with capacitive touchscreens. The hand wearable also includes a vibration module for haptic feedback. Meanwhile, we utilize the gesture tracking capability of the AR headset to determine how the UI elements are manipulated. We will explain the detailed authoring workflow with the following example. At first, the user specifies the screen area and the interaction area by drawing a bounding box around the instrument. The system won't read the pressure sensor data until the hands are within the interaction area. Each operation is classified with our decision tree algorithm based on the pressure and gesture data recorded during the operation. After recognizing each operation, the system generates arrows with dynamic scales and orientations to match the operation. For button operation, the arrow is displayed at where the button is pressed, and its orientation is aligned with the index finger. For switch operation, the arrow points from the finger whose pressure sensor detects the pressure to the finger whose pressure sensor does not. For slider operation, the arrow's direction and length match the finger's trajectory when manipulating the UI element. For knob operation, the knob's rotated angle is displayed as numbers in degree. It is the same as the angle between the vectors that points from the thumb to the index finger at the start and end of the operation. The angles of consecutive turnings on the same knob are accumulated. Meanwhile, the arrow size is proportional to the distance between the thumb and the index finger. Arrows for screen touch and swipe are similar to button and sliders respectively, and will be displayed in different colors. After the completion of each operation, the system will capture an image on the previously specified screen area. The raw image capture with the AR headset is automatically processed through cropping and perspective transformation based on the red bounding rectangle drawn earlier. The user can also record his or her voice by performing a pinch gesture, which is translated into text displayed on the side. For novice users who learn using the author tutorials, InstruMentAR can also detect and track each of their operations. InstruMentAR is able to detect the potential arrow before the operation is completed. For button or switch operation, the system extracts the finger's location when the pressure sensor detects a touch event. It helps the system to determine if the user is about to operate on the wrong UI. For slider operation, the system determines if the user is to move the slider in the wrong direction by checking which finger sends the pressure signal. For knob operation and screen swipe, the system detects the wrong direction through fingers movement. The moment a potential arrow is detected, the system will immediately issue a preemptive warning through visual and haptic feedback. After each operation is completed, InstruMentAR compares it with the authored operation to determine if it is performed correctly. If correct, the AR tutorial will automatically advance to the next step. In the user study, we first compared the authoring mode of InstruMentAR with a traditional authoring system where tutorials are created manually through direct manipulation of virtual content. Then, we compared the access mode of InstruMentAR with a traditional AR tutorial system where users need to manually advance the tutorial. Meanwhile, no feedback is provided based on the user's operation, as traditional system cannot track novice users' operations. With minimum setup effort, InstruMentAR can be easily applied to digital instruments across various domains.